All right, shout out to my F block class, 2018 here. We are making the 2.5b compound inequalities video. And what we want to do is we want to put these two inequalities into one inequality, and then we want to graph them. So you should have this on your handout. And make sure you put today's date down as well with the title of the notes. So the date for us today is 10/29, but you're going to want to put today's date, of course, if that's not the date that you're watching the video. So 10/29, you got to have that up there. So the first thing we're going to do is we're going to put the inequalities into one inequality and then graph them. So let's just think about what this means. We have x is greater than 3 and x is less than or equal to 7. How can that be put into one sandwich inequality? What are your thoughts on that? Tell me what you think. Yes, Jade. You have to put the number with the least value, the lowest number at the beginning. That's perfect. That makes so much sense. So the smallest number here, in my opinion, is 3. So that's going to be all the way to the left. 3. And now I want to look at this symbol and I want to say, is the 3 being eaten up or not being eaten up? What are your thoughts? Tell me. Is the 3 being eaten up? Just shout it out. Is it being? That's right. It is not being eaten up. It's smaller than x. Okay, so we've done that, and now we just need to add on this part right here. So if I was going to add on the 7, what symbol could I put in? How could I finish this thing off? Can't I just pop this right here? Yeah. Right? So what does that say? X is less than or equal to 7. So this is one inequality. This is the sandwich inequality. And this makes a lot of sense when we look at a number line because really all the numbers are going to be between 3 and 7. So I'm going to go to 3, and then I'm going to go 4, 5, 6, 7. And I'm going to think about 3, and I'm going to ask you whether I have an open, you can shout it out, an open or a closed circle at 3. Open at 3. Here, the red one, okay? So this guy's open because we have no line underneath it. Notice that there's no line underneath it. So if that's open, that means there's no line underneath it. And we want to go greater than that because the x is being eaten, so we want to go this way. I'm just giving you a gist of where we're going. And then we have the 7, right? And if we are at the 7, we want to be open or closed? Closed. Very good, because there is a line underneath here. That means it's closed at 7. And that means we're going to go to the right. And where do these two things intersect? Well, the whole answer is really just this. Open here all the way up to here. This is what we want for our answer. This is our answer, okay? So we've now put the inequalities into one inequality, and we've graphed them, okay? Does that make sense? So perhaps we'll try one more. We'll see how that goes. So maybe you could pause the video and try this problem. You can always rewind and go back to the last one. You can see what we did here. We put the smallest number first with this and thing, and we kind of switch the symbols around as necessary. So try number 2. Pause the video and try number 2. Now, as you pause the video and you're trying number 2, you may try number 3 and 4 if you're feeling comfortable with it. I might cover 1 or 2 of those problems, but if it's going smooth, if it's going swimmingly, as I like to say, go ahead and pause the video and keep on going. Try 3, try 4. I think you can make those happen. They're not too bad. Okay, so just a reminder, you're trying number 2. If number 2 is fine, you're going to just keep this video paused and try number 3 and try number 4. So 2, 3, 4, because it seems like they're not too bad. All right, so you'll notice that these answers, a lot of these are and problems, and and problems pretty much always go in. And goes in, basically. Now, there might be a couple of situations where they don't quite do that, but in general, that's pretty much how it works. So I'm hoping that 2 went pretty well, and maybe even 3 and 4 went pretty well, but what I want to do is go over 5 with you, okay? Just in case you didn't quite get there to 5. And feel free to do all the problems, or maybe if you skip one, that's fine. So let's look at this first one here, and let's talk about the smallest number. Which one's smaller, -11? So we'll put that to the left. Yes. Go ahead. It's okay. Tell me what to do.
So you put -11 on the left.
Yep, so -11 on the left.
And then it's less than x.
Right, because it still has to eat the x. And then what do we do?
And then you put -3 on the right. And
Yep.
-3 is greater than x.
Right, so make sure that 3 is greater than x, or x is less than 3, which is really exactly, this is written exactly the same as this. So that's pretty much where we want to be. And now we want to graph this. And let's just graph it all in one foul swoop, as I like to say. So negative 11, I don't know, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, I think is here. 1, 2, 3, so here. So we want to be open or closed at the green negative 11. Open or closed? Go ahead. Open, thank you. Thank you for the feedback. And we're going to go this way, of course. And how about at the blue dot? Are we going to be open or closed? Open as well. So we got two open dots, right? And we just want to connect everything in between because we want to go greater than the lower number and less than the higher number. This is what we should be getting. So take a minute, go through that example if you need it. What's the trickiest part? I think the trickiest part is understanding that this is the smallest number and that you need to flip the inequality around to get here. If you can understand this, the x always has to get eaten in this situation, right? If the x is getting eaten in the original problem, the x must get eaten in the rewrite, right? If the x is not being eaten in the original problem, then the x is not being eaten in the rewrite. That's how you do these types of problems. So I'm going to take a minute and just going to go on because I feel like we're pretty good here. And I want to cover a couple of word problems and also give you some time to practice. So let's do it. So we got this cell phone thing. And there's a couple of questions that are being asked here. And let's see, my screen is a little bit weird here, but here we go. So we have this cell phone with an operating temperature from, I don't know, 0 to 35. So, you know, you ever leave your phone out in the cold and it just kind of just shuts down? Not very often, but usually in the heat, right? It will say like heat warning or something, and it won't turn on, basically. So electrical devices should operate within a specific temperature range. What we're going to do is we're going to write an inequality, a compound that represents the possible temperatures of the smartphone. But instead of going in Fahrenheit, can we just go in Celsius for now? We'll start with Celsius. Okay? So let's talk about that. So what would be the lowest temperature we could allow? 0. Do we want x to be greater than that or less than that? Our phone. Do we want our phone to be greater than 0 or less than 0? Okay, so our phone is x, so we want our phone to be greater than 0. Yeah, I guess it can operate at 0 exactly. And then do we want our phone to be less than or greater than 35 degrees? Less than. We don't want it to be hot, like super hot, so this would be the inequality. So this is really part A, okay? Now if we're going to change that over to Fahrenheit, we're going to need to do some more work. But I'm going to leave that alone for today just to understand the basic idea of it. Now, can you just pause the video and think for a moment of a situation, right, in which the temperature could be below the operating range and one in which it could be above? So just think about it for a second. What would that be? The freezer? Did you say? Oh, a blizzard, okay. I was like, the freezer? Who puts their phone in the freezer? Yes, if there's a blizzard and you leave your phone in the car or you drop it in the snow, it's going to be probably below the operating range of 0 degrees Celsius, which is 32 Fahrenheit. And what's a situation where it might go above the heat temperature, yes? Sure, drop it in lava for a YouTube video, yes?
Or if you're out by the pool and
right. Yeah. I always feel like when you're at the beach and you don't put it underneath the towel or something or in the bag, it gets so hot if you don't like block the sun. So those are situations where it could be below or above the temperature it should be. So let's pause the video. Let's stop the video there. We're just going to keep it kind of short, and you'll take some time to practice solving these. Solve them the same way as you would on the last video, and I will see you soon.